The last piece of your homework for section 5.3 is 4 conceptual questions. So you should be able to answer all 4 of these based on the notes from the rest of 5.3 section. It takes a little bit of critical thinking skills. So I want to provide the solutions for you. But before you read and watch my solutions, so go ahead and pause this video or stop this video completely and go try those 4 and give yourself a little time, a little struggle time to try it. Play with the properties, see if you can get one side to equal the other, and determine if these 4 equations are true or not. So I'm going to ask you to pause the video or stop the video and go try those on your own, and then you can come back here to check that. All right, so I'm going forward now, assuming that you've already tried these on your own and ready to just kind of explain those answers a bit. So to prove these equations are true, I like to start with one side of the equation and try to get to it to be equal to the second side. So, for example, for 63, I'd like to start with the left-hand side, which is log of e, and I think, okay, well, how else could I express log of e using the properties we just learned in this section? Sometimes I use parentheses even though it's only one letter because, or else it looks like loggy. The way I write it, my handwriting kind of runs it together. So I'll write it like that today. All right, so I'm looking something with a fraction, and I need to get it to base e. So it needs to get transferred to a natural log. So I'm going to apply the base change formula to this. So I'd get the natural log of e over the natural log of 10. That's my base change because there's a 10 here. That's the common log. So I used the base change formula to get that. And then I know that natural log of e is just 1 because that's natural log is a log base e of e. So that's e to what power gives me e, which is 1. And that's property 2, which I wrote here. So that property gives us that natural log of e is 1. So I have now my right-hand side. So I say, oh, hey, that's equal. The left-hand side is equal to the right-hand side now. So therefore, this statement is true. All right, so if you needed a little help on this and you think you can apply those skills to 64, 65, and 66, then go ahead and pause this video and try those now. Or try them again, since I know you've already tried them once. But now that you've seen 63, go ahead and try those now. And pause this video to do so. Okay, so assuming you tried 64, again, I'm going to start with the left-hand side, which is the natural log of e. And I want to say, okay, well, what can I do to that to make it look like this? Well, natural log of e, I know that's 1, right? Because of property 2. We've already applied that to the previous question. So we'll use that again, and we'll get the natural log of e equals 1. I'm actually going to do a little different technique this time. I'm looking at the right-hand side now. I can only look at one side at a time because I don't know this is equal. So I can't use that property of equality, but I can look at one side at a time. So now looking at the right-hand side, I have 1 over log of 10, and I know that common log is base 10, so that's log 10, base 10 of 10, again, is 1 for that same property. So we're using property 2 again there. So now these are both equal to 1. So that means that the left-hand side does equal the right-hand side, which tells me that this is true. All right, going on to number 65. For 65, I'm going to start on the left-hand side. I have natural log of x, y cubed. And I'm going to use that power rule, or the seventh property, power rule, to bring that 3 down in front, and I get that that equals 3 times the natural log of xy. And then I can use the product rule to expand. Notice on the right hand side it has it expanded, so my goal was to get it expanded, but I couldn't really do that while the 3 was still there. So I had to bring the 3 down in order to expand. So expanding that, I get natural log of x plus natural log of y. Now I'm trying to get to this right hand side, but I can't do it because I can't put that 3 back as an exponent now because it's no longer multiplied by a single log, it's multiplied by 2. Let's see, what else could I do? I could distribute that 3. That way I could put it as a exponent, which gives me natural log of x cubed plus natural log of y cubed. But that exponent is on the cube. It's on the x and the y. It's part of the x and the y. That's how the exponents on the logs work. So it's not this. It's actually this. So that is not equal to what we're seeing on the right hand side. So these are not equal. So I'm going to write not equal. This is not equal to the natural log of x plus natural log of y cubed. So since it's not equal, this is actually false. This is not equal to the right-hand side. Okay. And then 66. I'm going to start with the left-hand side again. So that is natural log of a over natural log of b. And trying to get to the right-hand side, I see, okay, well, I got to change the base. I need to get to that common base of 10. So to do that, I'm going to do that to the a and the b. So I'm going to write a big giant fraction bar for this fraction bar because each of those, the numerator is going to be a fraction and the denominator is going to be a fraction when I change the base. So when I change the base, I get natural log of, oh, nope, I want to change to a common base. Log a over log of b, and the denominator to change to base 10, I get log b. Whoops, I messed up, I'm sorry. That's not a log b. That is a log e, right? I'm changing from base e to base 10. Now in the denominator, I have log base b to log base e, because remember, these are base e. So I'm changing from e to 10. Okay, so this will be easier to, this is the base change formula. Now I can evaluate this. It'll be easier to evaluate if I spread it out like a division. So I'm using this fraction bar. I'm going to rewrite that as a division problem. So I have log of a over log of e divided by log of b over log of e. And to divide fractions, it's easy as pie. I just flip the second and multiply. And when I multiply across, I can first reduce the log of e, both cancel. And then I'm left with my reduced form of log of a over log b, which is my right-hand side. So I now have the left-hand side equals the right-hand side, so this must be true. So there's those 4 conceptual problems from wrapping up section 5.3.